Hello friends, welcome to Susan and John MathTube, a 24/7 math tutor. And this is the first lesson in our exam preparation series. And these video lessons are specially prepared for the first year, first part students of the Institute of Engineering, IOE, in TU affiliated colleges. And before we start, the first thing, how to use the video lessons effectively and efficiently. So point number one, we are going to learn mathematics. And when we learn mathematics, make sure you're always ready with a pen and paper. The reason is math is not like a novel or a newspaper where you can read and gain knowledge. If you want to be good in mathematics, then you should be always working out the problems. So be ready with a pen and a paper before you start watching the videos. And point number two, work out all the problems along with us. When you work out the problems with us, you become more confident in the topic which we'll discuss. For example, today's topic is tracing of conics. So if you work out the problems, we'll be doing 3-4 problems. So make sure you work out all the problems along with us. Number 3, this is a huge advantage of the video lessons. In a live lecture class, you cannot interrupt your lecturer and ask him or her to repeat the lecture again and again and again. But in video lessons, you can pause the videos at any time and you can repeat the videos any number of times till your concepts are crystal clear. And point number 4, once you complete this video lesson, make sure you take any math book affiliated to your university and work out a lot of problems. Look at this. When you watch the video, your concepts become clear. And when you work out a lot of problems, you'll be very good in that topic. And the last one, point number 5, once you're confident, take some past year's question paper and try to work out the questions by yourself. If you're able to complete the questions by yourself, then congrats, you used the video lessons effectively and efficiently. And with that, let's start the first lesson, that will be tracing of conics. Okay, I'm sure you have learned conic sections in your class 11 and class 12. Conic sections are nothing but cross sections of a cone. So it's a 3-dimensional figure, but still I'll try to draw it in our 2D screen. So if you cut a cone with a plane in this manner, you'll get a circle. And if you incline it a little bit, you're going to end up with an ellipse. And if you cut this corner, you get a parabola. And to be honest, this is a cone. So if you plan to cut like this or in this manner, you get another system called hyperbola. Anyway, you're familiar with the conic sections: circle, ellipse, parabola and hyperbola. Now, in class 11 and class 12, graph means Cartesian coordinate system. You'll always start with the XY plane. Even today, if I ask you to draw a graph, or if you want to plot a graph, the first thing you'll do is you'll draw the x-axis and y-axis. But that is called the Cartesian coordinate system. But today we are going to try and plot these things in the polar coordinate system. In polar coordinate system, instead of our x-axis and y-axis, what we do is we take a point and we call it the pole. And then we take one line, just like our positive x-axis, and that will be called the polar axis or the initial line. And now if you want to plot any point, The coordinates will be given by the length from the pole. Let's say this is the pole. Let's give, and the coordinates will be 0, 0. Okay, now we measure this distance, and that will be r. And we measure this angle, and that is our theta. So this coordinate will be given by r comma theta. In our Cartesian system, what we do is we measure the x distance and this height, and the point will be called x comma y, where x will be this and y will be this height. So look at this. This is our Cartesian system and this is our polar system. Now let's have a few examples. Suppose you want to plot 3, 90 degree in the polar coordinate system. Look at this. One will be length and the second one will be angle. So the first thing to do is you take the pole and a line, and that line will be called the polar axis or the initial line. Now suppose you want to plot 3, 90 degree. Now look at this. This direction is theta is equal to 0 degree. And you will always measure in the anti-clockwise direction. So what you do is you move in the anti-clockwise direction 90 degrees, because the angle is 90 degrees, and that means this will be our direction. And now look at this. In 90 degrees, this direction will be positive and this direction will be negative. And we need positive 3. So I go 1, 2 and 3. So this point will be 3, pi by 2. At the same time, if you wish to plot 2, pi by 6. Pi by 6 is 30 degrees. So what we do is we start from the initial line and then I will move 30 degrees in the anti-clockwise direction. And then look at this. This is positive direction. This is the positive direction and this will be the negative direction in 30 degrees. So I have to move 1, 2 units. So approximately this will be 2, pi by 6. At the same time, if you want to plot 3, 180 degree, if you want to plot 3, 180 degree, what you do is again you start from here, the initial line, and in the anti-clockwise direction move 180 degrees. So this will be the positive side in 180 degrees. Now don't get confused with our Cartesian system. This is a completely different system called the polar coordinate system. So you start from the initial line and move 180 degrees. Now look at this. This is the positive direction. And this will be negative direction in 180. So 1, 2 and 3. So this will be 3, pi. Okay. So let's try once more. Now I want you to plot 2, 0 degree and 3, 3 pi by 2 and minus 4, pi. Clearly these are the polar coordinates. So what we do is we take the pole and the initial line, and now look at this. We have, this is our 0 degree. So 2 units, and this is the positive direction of 0 degree. Everything is measured from here, and this is the negative direction of 0 degree. So 2, 0 degree means 1, 2. So this coordinate will be 2, 0 degree. Now 3 pi by 2 is 270 degree. So again we start from here and then move 90, 180 and 270. So we reach 270 degree. Now look at this. This is the positive part of 270 degree and this is the negative part of 270 degrees. So we move in this direction because this is a positive coordinate. So I go 1, 2 and 3. So this will be 3, 270 degrees. And now let's go for the last one, 180 degree. So again we start from our initial line 90, 180. So I reach 180 degrees. So this will be the positive part of 180 degrees. So naturally this will be the negative part of 180 degrees. Okay, so I had to go -1, -2, -3, -4. So this will be -4, pi. Now look at this. I'll show you one more thing. 4, 0 degree. Just think about it. 4, 0 degree will be the same point because 0 degree means this line and this is the positive side of 0 degree. So this is same as 4, 0 degree. So point number 1, in the Cartesian coordinate system, every point will have a unique representation. But here the representation of a particular point need not be unique. This is the best example because 4, 0 degree and -4, pi represents the same point. I'll repeat, 4, 0 degree and -4, pi represents the same point. Okay, with that, let's start. Now look at this. In your +1, +2, you might have learned y square equal to 4ax represents a parabola. I'm going to add a little bit. Y square equal to 4x represents a parabola in the Cartesian coordinate system. That means in our xy plane. When you change the Cartesian equations into polar equations, it will be in terms of r and theta. And the equations will look different. And the derivation is very easy. Let's derive it. So look at this. We have the xy plane. And for the time being, let's imagine this point is the origin as well as the pole. So this will be the positive x-axis will be doing a dual job. That is, it will act as the positive x-axis and our initial line. Now in the Cartesian system, I'm going to take a point x, y. So I have to move x distance and y distance. So in the Cartesian system, this point will be called x, y. While in the polar system, the same point will be called r and theta. And that implies in the Cartesian system, this distance will be x and this height will be y. And in the polar system, this length will be r and this angle in the anti-clockwise direction will be theta. Now look at this. We have a right angle triangle. And if I calculate cos theta, I will get x by r. And by calculating sin theta, I get y by r. So that x is equal to r cos theta and y is equal to r sin theta. Okay, now this relation or these relations tell me if I know r and theta, then I can get the xy equivalent. And at the same time, if I apply Pythagoras theorem, I will get r is equal to root under x square plus y square. And tan theta will be equal to y by x. And that gives me theta is equal to tan inverse y by x. And these relations tell me if I know x and y, I'll be able to get the r theta equivalent. I'll give you a very simple example. We have our circle the standard circle x square plus y square equal to a square. You have to recollect this from class 11. So this equation represents a circle, and this equation represents a circle in the Cartesian coordinate system because it is in terms of x and y. Suppose I want to convert this into the polar coordinate system. All I have to do is I'd replace x with r cos theta and replace y with r sin theta. And once I do that, I'll get r square cos square theta plus r square sin square theta, which you can take r square common, and gives me r is equal to a. Look, it's the same thing. It's the same thing. This is a circle in the polar coordinate system. This is a circle in the polar coordinate system with radius a. But when you look at the equation in the Cartesian system and the polar coordinate system, they look entirely different. In the polar coordinate system, it is r is equal to a, and in the Cartesian coordinate system, it is x square plus y square equal to a square. Now let's come to the point. We have to learn the three conic sections, parabola, ellipse, and hyperbola, in the polar coordinate system. I'm not going to discuss the derivation here, but the equations will be r is equal to dE by 1 plus or minus e cos theta, or r is equal to dE by 1 plus or minus e sin theta. There is a derivation behind it. If you want, you can check it. You can search online for the derivation, but for your examination, you should be more focused on the equation. So look at this. This is an equation in r and theta. So clearly, this is defined in the polar coordinate system. And you remember E, I guess. E is the eccentricity of the conic, and the eccentricity will decide the shape of the conic, whether it is a parabola or a hyperbola or an ellipse or a circle. And if E is equal to 1, you'll get a parabola. And E is less than 1, you're going to get an ellipse. And if E is greater than 1, of course, you'll get a hyperbola. And if E equal to 0, the picture will look like 0, that is a circle. There are 4 equations here. One is plus, another is minus, another is plus, oops, I forgot that, and minus. Okay, now look at this. If you ever see cos theta in a conic's equation, then remember it will be along the initial line. For example, the parabola may look like this, or the parabola may look like this. At the same time, if your equation contains sin theta, you're going to get something like this, or in this format. Okay, now if you're talking about ellipse, the ellipse will be, in cos theta, your ellipse will be something like this, and in this case, your ellipse will be something like this. And we'll be discussing about hyperbola only in the next video. So let's start with the problems. So are you ready with the pen and paper? Okay, so start. Let's write the question. Sketch and describe. It's the first question. Sketch and describe r is equal to 6 by 3 plus 3 cos theta. Okay, so the first thing to do, you have to compare with the standard equation. So I'll write the standard equation here. R is equal to dE by 1 plus e cos theta. I forgot to explain what is this d. I'll be explaining that in a minute. So this is the standard equation. So look at this. We need 1 here. Is it 1? No. So let's divide throughout by term by 3. So I'm going to get r is equal to 6 by 3, that is 2. The whole divided by 3 by 3 is 1 plus again 1 cos theta. Now I can compare with the standard form. So I'm going to get DE is equal to 2 and E is equal to 1. I told you a few minutes back, if E equal to 1, then the conic section will be a parabola. In your exam, you have to explain, since E equal to 1, we get a parabola. Now, the second thing to find is D. So you just substitute the value of E, so we get D equal to 2. Now look at this, D represents the distance between one focus and the vertex. Of course, in the case of parabola, there will be only one focus, but in the case of ellipse and hyperbola, there will be foci, there will be two of them. So D represents the distance between focus and vertex. So look at this, D is equal to 2. Now D represents the distance between focus and the directrix. So remember, D represents the distance between focus and the directrix. In the case of parabola, there will be only one focus. But in the case of ellipse, it will represent the distance between the first focus and the directrix, and also the other focus and the directrix. And both will be same because it's a symmetric picture. So once more I'll tell you, in your exam, first you have to explain, since E equal to 1, the given conic section is a parabola. The second thing to do, since D is equal to 2, you must write the distance between focus and the directrix is equal to 2. Now the third thing to do. Okay, so we got D is equal to 2 and E equal to 1. Now the third thing, we need a few points. We need a few points so that we can plot. And we take only minimum number of points so that we can have the rough figure really fast. So I'm going to put theta is equal to 0 degree because it's kind of like x and y. If you want to plot a graph in the Cartesian system, you give random values for x and you can collect the values for y and you'll get the coordinate system x comma y. We do the same thing. Here I'm going to put theta is equal to 0, then 90 degrees, and you know 90 degrees is pi by 2, and pi, and finally 270 degree. And I'll try to plot the conic with the help of just 4 points. And then I find R. We can plug in those values over here. You can use a calculator, don't forget. So cos 0 degree or cos 0 in radian, cos 0 is 1. So we are going to get 6 by 6, that is equal to 1. And then you plug in 90 degree. Cos 90 is 0. So this whole part will be gone. 6 by 3, that is going to give me 2. And cos 180 degree. You can use the calculator, and if you know the values, that's great. So I'm going to get 3 minus 3, that gives me infinity. And I'm not going to plot that. I'm never going to reach infinity. Yeah. So cos 270 degree. Cos 270 degree is again 0. So 6 by 3, I'm going to get 2. Now you can write r comma theta, because like x comma y, the Cartesian is r comma theta. So the first coordinate will be 1 0, then 2 pi by 2, and then infinity comma pi, and 2 comma 3 pi by 2. Okay, so with the help of these 4 coordinates, let's plot our parabola. Okay, so let's start with our initial line. So we have the pole here, and look at this. The equations are designed. You didn't learn the derivation, but these equations are designed in such a way that the pole will be one of the focus. That is how they derive it. So you can write the focus to be at the pole. So this is a advantage. Like in the Cartesian system, you take the vertex at the origin. In the Cartesian system, the pole will be the focus. Okay, now 1 0. So that means I have to move 1 unit And when you plot, make sure you use a scale. Yeah, so we have 1, 0, and now the next point 90 degrees. So how do you plot it? This is 0 degree, and you move anti-clockwise, and this is positive. So 1, 2. So this is our 2, pi by 2. And the third point we cannot plot, and that actually shows the parabola will look like this, because we are not able to plot infinity. Because 180 degree means we'll be here, and infinity means we cannot plot. And the last point 270 degrees. So 0, 90, 180, 270, and 1 and 2. So we have it here. Now that's it. We can plot. I think you can see the major points. Okay, so let's plot. Are you able to see the parabola? So we have the parabola here. Yeah. Okay, so we have the focus. I told you the focus will be same as the pole, and this part is called the vertex. So the vertex is 1, 0 degree or radian. And we have to draw one more thing, the directrix. And for that I need the value of d. Look at this, you already found the value of d to be 2, and I told you d is the distance between focus and directrix. So this much is 1 unit and 1 more unit, so our directrix will be here. You can use a scale so that your picture looks pretty good. Okay, now we have to write the equation of this line, and the equation of the line is x is equal to this distance, that is 2. So 2 cos 0 degree. Okay, I'm sure you didn't understand that last part. In Cartesian coordinate system, there are a few standard lines which are parallel to the initial line, and lines which are perpendicular to the line. Now look at this. Suppose you have a line which is perpendicular to our initial line. So the equation of this line will be x is equal to, you have to measure this distance. Let's say this is d. So the equation will be d cos 0 degree. Because if you want to reach this line, it's in the direction of 0 degree. At the same time, suppose you have the initial line like this, and a line which is perpendicular to the initial line. But if I want to reach this line, I have to turn 180 degrees. Look at this, I have to turn 180 degrees, but it's still in the same axis. So this equation will be x is equal to, let's say this distance is d. So it will be d cos pi. Pi means 180 degree. Okay, I'll show you 2 more lines. Suppose this is our initial line, and our line is parallel to the initial line. That means if I want to reach this line, I have to turn 90 degrees. Then I have to move up. And let's say this distance is d. And this equation will be y is equal to d sine pi by 2. At the same time, suppose this is our initial line, and our line is parallel but below the initial line. That means first I have to go 0, 90, and that means first I have to go 90, 180 and 270, and then I can reach the line. And suppose this distance is d, and the equation will be y is equal to d sine 3 pi by 2. So look at this, we discussed about 4 different lines perpendicular to the initial line and lines which are parallel to the initial line. and you have to be sure with these equations in the polar coordinate system, and that's very easy. So if it is parallel but beneath the initial line, it will be sine 3 pi by 2, and if it is above the initial line, it will be sine pi by 2, and if it is perpendicular to the initial line, it will be in terms of cos. So let's go back, and I'm sure you understood this. So that's it. You just explain the focus is the pole 0, 0, the vertex is 1, 0, and the equation of the directrix is x is equal to 2 cos 0 degree. That's it. Now let's try one question from your past paper, and I found this one. So this is a question from 2072, Karthik. Okay, so let's start. So they have given an equation r is equal to 10 the whole divided by 3 plus 2 cos theta. So tell me, what is the first thing to do? We have to compare with the standard equation. And the standard equation is dE by, I can use 1 plus or minus. I'm going to use plus because it's plus in the given question. And then I'm going to write E, and I can use sine or cos, but it is already given cos. So I'm going to compare it with cos. Now look at this. This is equal to 1. This first term is equal to 1. So the first thing I'm going to do is I'm going to divide every term by 3. So I get r is equal to 10 by 3, the whole divided by 1 plus 2 by 3 cos theta. Now comparing with the standard equation, I get d into e equal to 10 by 3, and e is equal to, look at this, e is equal to 2 by 3. 2 by 3 is less than 1. Since the denominator is bigger than the numerator, we have e less than 1. That means the given conic is an ellipse. Okay, now the next thing, we will plug in this value over here. So we get d into 2 by 3 is equal to 10 by 3. Cancelling this, we get d is equal to 5. And by the way, what is d? Yeah, the distance between focus and directrix. So the distance between focus and directrix is equal to 5. But remember, this is an ellipse. In an ellipse, there will be 2 focus, that means foci, and 2 directrix. So the distance between the first focus and the directrix will be 5 units, and the distance between the second focus and the directrix will also be equal to 5 units. So you can write these things. D is equal to 5. That is, distance between focus and the directrix is 5 units. And second thing you can write is E is less than 1. So the given conic will be an ellipse. And one more very important thing, since we have cos theta in our equation, the ellipse will look like this. If it was sin theta, the ellipse would have been something like this. So shall we start? Now what we do is, we will put some standard values for theta, 0 degree, 90 degree, 180 degree, and 270 degree. And let's calculate the values of r. Cos 0 is 1. So 10 by 3 plus 2, that will be 2. Cos 90 is 0. So we get 10 by 3, that is approximately 3.33. And cos 180 is minus 1. So we get 10 by 3 minus 2. That will be equal to 10. And cos 270 is again 0. So we get 10 by 3. So the coordinates in the form r theta are 2, 0, 10 by 3 pi by 2, 10 comma pi, and 10 by 3 comma 3 pi by 2. Now before we start, one very important thing. our ellipse will look like this. These two endpoints of the ellipse are called the vertices. So we have to find V as well as V dash. And this length or this much is called the major axis of the ellipse. And the length of the major axis is equal to 2a. And this is called the minor axis. What do you call this? The minor axis. And the length of the minor axis is equal to 2b. And the relation between a and b is controlled by the eccentricity, that is b square is equal to a square into 1 minus e square. Okay, and the foci will be here and here, so s as well as s dash. And the meeting point of the major axis and minor axis is called center. And there will be two directrix, one towards this side and one towards this side. And this distance is d, and this distance will also be equal to d. So we have to find the following things: the vertices, foci, center, and the two directrix. So let's proceed. So as usual, I'll start with my initial line. So the first point is 2, 0 degree. So in 0 degree, I'm going to plot 2 units. You can use a scale. So I'm going to write 2, 0 degree. Okay, now the next point, 10 by 3. 10 by 3 is approximately 3.33 in the direction of 90. So I had to go 90 degrees. That means up. So it will be like 1, 2, 3.33. It will be somewhere here. So I'm going to mark 10 by 3 pi by 2. So that's the second point. Now the third one, in 180 degree, it is 10. So starting from initial line, I had to go 180 degrees, and positive 10 means this direction. So that will be 1, 2, 3. In your exam, use a scale. 5, 6, 7, 8, 9, 10. So this will be 10, pi. And the last point, okay, that will be exactly symmetric. So it's like 1, 2, 3 and a little bit, 3.3. Okay, so this is 10 by 3, 270 degree. Okay, so I hope you're okay with these 4 points. We have only 4 points, 1, 2, 3, 4, and we have to get this picture. Okay, the first thing to do, I told you, these conic sections are designed in such a way that the pole will be the focus. So I got one focus. So look at this. So this point, our pole, everything is measured from here. So this will be our one of the focus. So I can see that this distance, I'll put yellow color here. So what is this distance? It's 2 units. So if you want the other focus, take a look at this standard picture. The distance between focus and vertex on the right side will be the same as distance between focus and vertex on the left side. So if I want the next focus, it is very easy. I go to this vertex. This is actually the second vertex and this is the first vertex. So I go to this vertex and I'll move 2 units backwards. So this will be the second focus. This whole length is 10 units. And I moved 2 units backwards. So the coordinate will be 8, pi. Think about it once more. Okay. Now another question. This is one vertex and this is another vertex. And the distance between vertex to vertex, can you guess? Yeah, you're right. This is 10 and 10 plus 2, 12. So the length of the major axis is equal to 12. And I told you major axis is denoted by 2a. So 2a is equal to 12. So a is equal to 6. Now look at this. Suppose you have a line. And let's say the line is 12 units long. So how do you find the midpoint? And that's it. You just subtract 6 units from any end. Either from this side or from this side. You move 6 units, you will be at the midpoint. So we have a equal to 6. So if I want the midpoint, it is very easy. I'll go to this vertex and move 6 units backwards. So 1, 2, 3, 4, 5, 6. And that will give me the center 4, pi. I'll repeat once more. This whole length is equal to 10. And 10 minus 6 gives me 4. So 4, pi. So I hope you're okay up to this. Now comes another calculation. Look at this. A is equal to 6. And we already found the eccentricity. The eccentricity is 2 by 3. So we use the formula b square equal to a square into 1 minus e square. And if you simplify, you'll get b square to be equal to 20. So b will be approximately 4.47. So now we know a, we know b. Okay, now at the center, right at the center, you move 4.47 units approximately 1, 2, 3, 4 point, let's say here, somewhere around here. And do the same thing beneath. 1, 2, 3, 4 point somewhere around. So can you see 5 points on the right side of the ellipse? 1, 2, 3, 4, 5. So what we do is we will plot this side of the ellipse. We'll have a rough sketch. I think you're able to see the ellipse now. So the ellipse is coming alive. So it goes here and here and here. Okay. Now you have to use your skill in symmetry and draw the other side. I'm not that good in drawing, but I'm sure you'll be very good in it. So try it. So this is how we get the ellipse. It doesn't look that good, but when you use a scale and a pencil, you'll get a really good picture. Now the last thing, for the last thing I had kept the value of d here. What does the d represent? The distance between focus and the directrix. And the distance between focus and directrix is 5. So look at this. I go to this focus. I hope you can see this. And I'll go 5 units. 1, 2, 3, 4, 5. Okay, that is my first directrix. And the equation is x is equal to, now you know, this line is perpendicular to the initial line and in the direction of 0 degree. So 5 cos 0 degree. And now for the second directrix, I will move to the next focus here. It's already 8 units far from the pole. So this is 8. And now I go 1, 2, 3, 4, 5. And I'll draw the second one. Okay, and that equation will be, can you guess? X is equal to, everything is measured from the pole. So look at this. From here to here it is 8. And focus to directrix distance is 5. That is D. So this equation will be 8 plus 5. 8 plus 5 is 13 cos pi, because it's in the direction of 180 degrees. So that's it. It looks like a mess. And in the examination, you have to write everything very clear. The vertices are V and V dash. And the focus, one focus will be the pole. And you have to write the other focus. And then you have to write the equation of the two directrix. and then of course the center. So let's try one more question from your past year's question paper. It's an old question. They asked this question in 2069. Anyway, we have an equation r is equal to 4 sec theta by 2 sec theta minus 1. But when I gave you the standard equation, I promised only cos and sine. So the first thing you have to do is you divide every term by sec theta. So here what we get is 4 by 2 minus, what is 1 by sec theta? Yeah, you're right, cos theta. Now second thing, we have to make this 1. So I'm going to divide each term by 2. So 4 by 2 and 2 by 2 and 1 by 2 cos theta. Now I'll write comparing with the standard equation dE the whole divided by 1 minus. This time I'm going to use minus because the given equation has minus. E into cos theta. I am going to use cos theta because in the given equation they have used cos theta. Comparing d into E is equal to 2 and d is equal to 1 by 2. Now tell me what to write next. Since E is equal to 1 by 2 is less than 1, the given conic section is an ellipse. And then we plug in this value over here. So I'm going to get d into 1 by 2 is equal to 2. So d will be equal to 4. And what does d stand for? The distance between focus and the directrix. Okay, so in your exam you have to write E is equal to 1 by 2 less than 1. So you're sure that it is an ellipse. And then you write the distance between focus and the directrix is equal to 4 units. And you can write one more comment. One of the focus will be the pole. So shall we start? So as always, I start with my initial line, and I'll strongly recommend use a scale and a pencil. Okay, so shall we start? Now the next thing to do is we have to collect some values theta and r. So we'll set theta equal to 0 and then pi by 2, pi and 3 pi by 2 as always. Now when we plug in 0, we get cos 0 is 1 and we end up with 4 over here. If you want, you can use a calculator. And when we plug in pi by 2, cos pi by 2 being 0, we get 2 by 1, 2, and then cos 180, and that will give us minus 1. So 2 the whole divided by 1 plus 1 by 2, that is 3 by 2, and that will be 4 by 3. And the last value cos, yeah, that is 2. Now let's start plotting. So in 0 degree, I had to move 4 units. So that will be approximately 1, 2, 3, 4. Okay, so I'll mark 4, 0. And one more thing, we have cos theta in the equation. So my equation gives an ellipse which looks something like this. Okay, now next. In 90 degrees, I had to move 2 units. So it's over here. So I'll mark 2, pi by 2. And in 180 degrees, so that will be over here, I have to move 4 by 3. 4 by 3 is approximately 1.33. So 1 and a little bit here. Okay. So that will be 4 by 3, pi. And the last point, of course, will be symmetric to this. So 1 and 2. Okay. So we have our vertex and another vertex. And here the complications will be slightly difficult than the other one. The first thing to find is the distance between the vertices. So you can see that V dash, and this point is one of the focus. So what will be this? This point is one of the focus. And you can see that the distance between focus and this vertex is 4 by 3. So if you want the other focus, all you have to do is you just move to the next vertex and move 4 by 3 units backwards. Now look at this. This much distance is 4. And I'm asking you to go backward. How much? 4 by 3. I'll repeat once more. The distance between focus and this vertex is 4 by 3. So definitely the distance between the other vertex and focus should be 4 by 3. But this total length is 4 by 3. So I'm going to move backwards 4 by 3 units. And 4 minus 4 by 3, that will be 8 by 3. So from here, that is approximately 2.67. So that means 2.6 somewhere here. So this will be our next focus, and that is 8 by 3 in the direction of 0 degrees. Okay, so we got both the foci. Okay, now tell me what is the distance between V and V dash. That will be 4 by 3 plus 4, because this much will be 4 by 3 and this will be 4 units. And that gives me 16 by 3. So the length of the major axis 2A is equal to 16 by 3. So A will be equal to 8 by 3. And 8 by 3 is approximately 2.67. And with this, we can find the center. So from any end, you subtract, I told you, if a line is of length 10 units, and if you want the midpoint, you just move 5 units in the direction of the midpoint from any end. You can do this, or you can do this, you're going to reach the center. Now look at this. The total length of our major axis, that means from vertex to vertex, is 16 by 3. That means A will be equal to 2.67. So the center will be this end minus 8 by 3. So that will be 4 minus 8 by 3. That gives me, so from here that will be approximately 1.33. So I have to move here a little bit, and this will be the center. So the coordinate of center I'm going to mark here. Center is 4 minus 8 by 3. That will be 4 by 3 in the direction of 0 degree. Now the last thing to do, we have to calculate B. We have A is equal to 8 by 3 and E is equal to 1 by 2. Now B square is equal to A square into 1 minus E square. That gives me B to be approximately 0.309. That means I go to the center and 1, 2 and 2.3. It will be slightly here, somewhere here. And I'll do the same thing here, 1, 2 and a little bit down. Now I hope you can see the 5 points, 1, 2, 3, 4, 5. With the help of the 5 points, we will draw the rough figure. So I get one side. And now with the help of symmetry, we go for the other side. So it's kind of like this. If you use a scale and a pencil, it'll look much better. So it's almost done. Now the last thing, D. The value of D is, what is that value? Let's check it. Yeah, D is 4. So from S dash, I have to move 4 units in this direction. So that will be 1, 2, 3, 4. Let's say it's over here. So let's plot the first directrix. And the equation will be x is equal to, look at this, we have to measure from the focus to this. I know this much is 8 by 3. And then I'm adding 4. So the equation is 8 by 3 plus 4 cos in the direction of 0 degree. And from the other focus, I have to move 1, 2, 3, 4. So my other directrix will be somewhere here, and the equation will be x is equal to 4 cos pi, because we are measuring from focus to directrix and that distance is 4 units. That's it. This was kind of complicated compared to the first question. Now let's try one more question before we wind this video. And by the way, if you have any difficulty in this method, please feel free to comment, or you can mail me at sjmathtube@gmail.com. Okay, so let's go for the last question. So try the last question. This is very important, because this is the first question we are doing with sine. So you can note the question. Describe and sketch the conic r is equal to 10 the whole divided by 3 minus 2 sine theta. And now this time I'm confident you'll be able to do this by yourself. Of course, let's do it together. So how do we start? Okay, first make sure this quantity is 1. So I'm going to divide throughout by 3. So right, the equation is 10 by 3 by 3 by 3 is 1 and 2 by 3 sine theta. Then you can write, comparing with the standard equation, dE the whole divided by 1 minus E sine theta. Look at this, I'm using sine because the given question is in terms of sine. And when it is in terms of sine, we know that it's going to be an ellipse, because E is equal to 2 by 3 and 2 by 3 is less than 1. So I'm going to get something like this. Okay, so E is equal to 2 by 3, so it's an ellipse, and D into E is equal to 10 by 3. I'll plug in the value of E, so that gives me D into 2 by 3 is equal to 10 by 3, cancelling all these things, D is equal to 5. And that means the distance between focus and the directrix is 5. So as usual, just start theta, and I'll plug in 0, pi by 2, pi, and 3 pi by 2. You can use the calculator and find the values. Sine 0 is 0, so I get 10 by 3, and sine 90 being 1, I'm going to get 10, and sine 180 again 0, so you're going to get 10 by 3, and the last one is going to give you 2, because sine 270 is minus 1. So we have our values here. So as usual, I'm going to start with my polar axis, or our initial line, and of course we need the pole, so this will be our pole, and as always the pole will be one of the focus. So shall we start? Yes. So the first point is 10 by 3 in the direction of 0 degrees. So I'm going to use 1, 2, 3 and a little bit here. So 10 by 3 comma how much? 0. Now my second point is in 90 degrees 10 units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I think it's better to use a scale. And in 180 degrees again 1, 2, 3 and a little bit here. That will be 10 by 3 comma pi, and this is 10 comma pi by 2, and of course 2 units down. So I'm going to erase this for the time being. So it will be somewhere here. Okay, let's say here. So it will be 10 comma 3 pi by 2. Okay, now let's remove this. Okay, now look at this. We have an equation in which we have sine theta, so that's why the ellipse is going to look like this. So we found one of the vertex here, so that will be 2 comma 3 pi by 2. Okay, now let's remove this. So look at this, our equation contains sine theta, that is why our ellipse looks like this. And one of our vertices is over here and another is over here, and 2 points on both sides. Now let's measure the major axis. Remember, the major axis will be here. So this is our focus 0, 0, and the major axis V to V dash. I'll call this V dash. So this is 10 units up and 2 units down, so that is 12. So 2a is equal to 12, so a equal to 6. And we also know that e equal to 2 by 3, and the relation is b square equal to a square into 1 minus e square. So b square is equal to 36 into 1 minus 4 by 3. Simplifying, we get b square equal to 20. So b will be approximately 4.47. Okay, so we have a and b. So the next thing we are going to do is we are going to find the center. So look at this. From focus to this vertex, this much, from focus to this vertex, it is 10 units. And our midpoint will be 6 units behind or down. Okay, so I'm going to count 1, 2, 3, 4, 5, 6. I'll strongly recommend use a scale. So that will be our center. So our center is 4 in the direction of pi by 2. I'll repeat once more. This total height is 10 and I came back 6 units. So that gives me 4 comma pi by 2. So that will be our center. And the next thing, okay, look at this. The distance between focus and one vertex is 2 units. So if you want the other focus, you go to the next vertex and come back or go down 2 units. So the focus will be 8 comma pi by 2. Because this much is 10 minus 2 will be 8 pi by 2. Now B, that is our minor axis, this length. So from the center, I'm going to erase this for a second. Yeah, from this center to this side we will move 4 units. So it's like 1, 2, 3, 4 and a little bit here. And on this side also 1, 2, 3, 4 and a little bit here. Okay, now we got our ellipse. It looks like this. I can see the 5 points. It looks like, I think you're okay with this. The ellipse looks something like a minion. Okay, anyway, use a scale and draw it properly for the exam. And now only one more thing left, that's a Directrix. And I kept the value of d somewhere here. Yeah, d is 5. And in this, the Directrix will be here and here. So from focus, what is d? D equal to 5. And what does d stand for? The distance between focus and the Directrix. So 5 units. So 1, 2, 3, 4, 5. So my first Directrix will be somewhere here. And the equation is y is equal to, look at this, this distance is 5. So 5 sine 3 pi by 2. Because this is in the direction of 3 pi by 2. And my second Directrix will be, I don't know if it will fit the screen. From the next focus I have to move 5 units. 1, 2, 3, 4, 5. I'm going to plot it over here. Okay, let's say this is our second Directrix. And that will be y is equal to, look at this. From focus to this much height is 8. And again this distance is 5. So 8 plus 5, 13 in the direction of 90 degrees. So that's the end. And in your exam, don't leave it in a mess. This is really a mess, but do the things neatly because neatness counts. So at the last you have to write the vertices are the foci are, and the equations of Directrix, and then the center. Make sure you write this, then only you'll get your 5 marks. Anyway, I'm going to wind up this video here. In the next video, that is lesson number 2, we'll be learning about the hyperbola in polar coordinate system. And if you like the video, please subscribe and share with your friends. So I'll be back with the next video very soon. So till then, bye.